Okay, so for our today's class, we will talk about plotting a quadratic graph. So as you can see from the board over here, I have an example of a quadratic graph shown to you. And usually, a quadratic graph is expressed with this equation over here. Y equals to ax squared plus bx plus c. Now, when you look at this equation, it might look very familiar to you because we have been using this equation in our factorization question. All right, we are factorizing quadratics, so this might look very familiar to you. Okay, and that is how we express a quadratic graph over here. Okay, now before I'll show you how to plot a quadratic graph, all right, let's understand how does the value of a, b, and c affects how the graph look. Okay, now a over here, there are only two options. It can either be a positive value or a negative value. So let's see what's going to happen if a is positive. So let's just say if a is positive, if the value of a is positive, the shape of the graph is going to be a U shape. All right, they are going to give you a U-shaped graph. All right. Okay, it's going to give you a U-shaped graph, again, like what you see over here right now. So if a is negative, all right, if a is a negative value, you will get the opposite. You will get an N-shaped graph, all right? So it's going to look something like this, all right? It's going to be an N-shaped graph, all right? It's going to look something like this, okay? Now, how I would like to remember this is I have a simple analogy to remember this. Now, just imagine A is positive. Positive is something very happy. So when you're happy, you smile, all right? That is how I usually like to remember that. So if A is negative, that's very sad, and you will have a frowning face over here, okay? So that is what the value of A will do to the graph. Now, of course, at the same time, I will show you what will happen to this graph when I play with the value of A. Okay? Now, when my A is positive, all right? Now, let's just show you what will happen if I make this negative. You can see the graph. So I'm going to adjust the A value. Currently, it's a smiling face, so you know A is positive. So if I were to make it negative, look at what happened to the graph. So you can see the graph open up, and then it goes, it goes like that. Okay? When you see this form, we know that the value of A, it's negative right now. Okay? So if you bring to positive, you will see it will have a smiling face. All right? Okay, so basically that is what the value of A does to the quadratic graph. Again, what if I were to increase the value of A? You can see the graph will get more and more narrower. If I were to reduce, or make the number more negative, we can see we'll have a frowning face, which is a sad face, and then it will get more and more narrower. Okay, so you can see an example over there. Now, how I would like to think about this, if A is positive and it's more positive, your smile will be more sharper. All right, that's how I usually remember this. So that gives me a good example for me to keep this as my long-term memory. Okay. All right, so that's the value of A. Now, what about the value of C? I will come to B in a while, but I just want to talk about C first because C is a simple one. The C over here is basically just the y-intercept. All right, it's the same as your straight line graph. Y equals to mx plus c. The C is basically represent the y-intercept. So in this case, where is the y-intercept over here? Y-intercept is defined as where the line cuts through the y-axis. In this case, is this point over here. All right, that's the point. That's the y-intercept over there. Okay, so of course I can play with the value of y-intercept. If I were to increase it, you can see the graph goes higher and higher up. All right, and if I were to reduce the y-intercept, it will go lower and lower, okay, and vice versa, okay. And if I make the A positive, I reduce the y-intercept, I increase the y-intercept. So basically that's it, okay. Now what about B over here? Now the B over here is gonna be a bit weird, right? But let me just show you what happened to the graph when you are playing with the value of B. So you will see over here, if I play with the value of B, you will see the graph will move either left or it will move to the right. Okay, you can see over here, all right? But how do I remember this? Okay, how do I remember this? So I'm going to give you a simple analogy, all right, for us to understand this better. So let's see what are we dealing with over here, okay? So over here, I'm going to write on the board. So what we are dealing with right now, it's in this equation, y is equals to ax squared plus bx plus c. All right, so let me write down here first. So we are dealing with y is equals to ax squared plus bx plus c. Okay, that's my equation for this quadratic graph. But the thing is, what do you think will happen if I make the value of a 0? All right, if I make the value of a 0 over here, it's gonna look like this. All right, and if I were to expand this, what I will get is y is equals to this multiplied by this, there's nothing. So what is left is going to be bx plus c. Okay, now do you recognize what is this? This is actually the equation of a straight line, correct? But in straight line, usually we will write as y is equal to mx plus c, correct or not? Now let me show you that this is true from this graph. Okay, so right now what I'm going to do is I will make the value of a 0. So let's see what happened to the graph. Okay, you can see when I make the value of a 0, it becomes a straight line. All right, because if I make the value a 0, I am only left with this, and this is the equation of the straight line, correct? And it's flat. And it's flat right now. Okay, now I am going to play with the value of b right now, and let's see what happened to this line. So I will increase the value of b right now. Let's see what happened to the line. Right now we see, oh, it slant upwards. It goes upwards. Can you see that? And hey, we know what is that, all right? We understand this as the gradient, correct? So in another word, we know that this b is actually the gradient. So if I were to reduce the value of b, what do you think will happen? All right, it will slant the other way. It is now a downward slope. That's our negative gradient, correct or not? So I will say over here that the value of b over here, that is actually a gradient. Okay, I'm just going to write down that. The gradient. Okay, so let's understand that first. Okay, so right now what I will do is I will play with the value of a again, so we can see how this value of b affects the quadratic graph over here. So let me make the value of a become 1. So 1 is a positive number, so I will get back a smiley face, like so. All right. So let's make the b positive. Let's see what happened. All right. Now I'm gonna just stick here, put here. All right. And I want you to look at this as I make the value of a 0 again. I want you to compare as I change this into linear and quadratic, so you can compare what's going on. So that is how it looks when it's quadratic, and I want to make this linear now. It's gonna look like this now. All right. And I'm going to change it to quadratic. So what I want you to observe, do you notice that this part of the graph doesn't change? Now let's look. Let's make this to a straight line again. All right. Okay, let's make this into a quadratic again. So do you notice that part is always going upwards? All right. So I'll do this one more time. So that part is always going upwards because it's a positive gradient. Okay. So what I will say here, this value of b is the gradient at y intercept. Okay, that is how I like to put it. Okay, so it helps me to remember better. So when I see an equation over here, I know how to visualize how the graph looks like. Okay, so over here, I'm gonna sketch out something for you. How do I know there's a positive gradient or negative gradient? But to show you this, I'm gonna fix some values over here. So what I'm gonna say over here is this. Let me say this. I will say when A is positive, when B it's also positive, all right? When C it's also positive, okay? Let's just give you this simple example. How will the graph looks like? So I have my axis over here, all right? So let's identify one by one how will the graph look like so you can understand better. So A is positive, I know it's a smiling face, and C is positive, so I know that the line will cut through the y-axis at the positive part of the y-axis, which means in this region over here, and the value of B is positive, which means the slope will be going upwards like this, cutting the y-axis upwards. All right? Okay? B, remember, it's a positive gradient. Positive gradient tells you the line go upwards this way, correct? So it goes upward this way and it will cut through the y-axis at the positive part. So it's going to look something like this over here. All right, the graph is going down and it's a positive gradient. The value of B is positive, so it's going upwards. And it cuts through the y-axis as the positive part. Okay? So if I were to sketch this out, it will look something like this. Oops. Okay, it will look something like this, all right? So again, what I want to, what we are focusing on is to look at the value of B over here. So over here, this zone, you can see the line is going upwards, which is indicating a positive gradient. And it is the gradient at the y-intercept, and remember this is our y-intercept over here, and it's cutting the positive part of the y-intercept. Okay, so that's the value of B. Now what about another example here? Let me fix over here. All right, let's just say when A is still positive, all right? Okay. Okay, let's make this negative, all right? So you can see some different examples. All right, and then I say here, when B it's also negative, but let's just say when C it's positive, okay? Okay, so for those of you, if you can imagine this, you can just pause the video and just assume how would the graph looks like. Okay, but in the meantime, I will just sketch it out for your reference. Okay, so let's understand first. When A is negative, it's going to be a sad face. C is positive, all right, so it means the y-intercept is going to be around this zone over here. This is a positive part of the y-intercept. And B, it's negative, so which means the line, it's cutting the y-axis at a negative gradient. Okay, so if I were to sketch a graph, it will look something like this. It's a sad face, all right, and it will cut through the y-axis at a positive gradient. Okay, so let me sketch this properly. Okay, so it's gonna look something like this. Let's see, A is negative, a sad face. C is positive, my y-intercept, it's cutting the positive area of the y-axis. And B is negative, look at this zone over here. The gradient, it's a negative gradient, all right, at the area of the y-intercept, correct? So that is how we know how the value of A, B, and C affects the quadratic graph over here, okay? All right, so of course, I'm gonna play with this so you can see better. So I'm gonna make the A value negative, B value negative, C value positive in this graph over here. So a negative value for A, All right, a negative value for A, a negative value for B, and a positive value for C. All right, so take a look at the graph. It matches with our sketching, correct or not? Okay, a negative value for A, a sad face. A positive value for C, my y-intercept is cutting the positive part. And then the B value, the gradient at the y-intercept is going downwards, going up, going down. Correct or not? So it looks something like this. Okay? So feel free, you can access this site. This is basically called Desmos Graphing Calculator. All right, you can just go to desmos.com. You can access this application over here and you can play with various kind of graph over here. All right, so that is how the value of A, B, and C affects the quadratic graph over here. Okay.